In May 2019, Victor Vescovo piloted a submarine to the deepest point on Earth, 7 miles down into the Mariana Trench, where pressure reaches 16,000 pounds per square inch, where the water is near freezing and no sunlight has penetrated for millions of years. The expedition was supposed to map unexplored sections of the ocean floor. What they found instead defied every scientific prediction about what can survive at those depths. The discoveries weren't just surprising. They were impossible according to existing marine biology. And the implications for what else might be down there are terrifying. The Mariana Trench is a crescent-shaped scar in the Pacific Ocean floor, 1,580 miles long and 43 miles wide. The deepest point, Challenger Deep, sits 36,070 feet below sea level. Mount Everest could fit inside with a mile of water above its peak. Only 4 humans had ever reached the bottom before Vescovo's 2019 expedition. Here's what makes the environment so extreme. At 36,000 feet deep, the pressure is 1,086 times greater than at sea level. That's like having 50 jumbo jets stacked on top of you. The temperature hovers around 34 degrees Fahrenheit. No photosynthesis. The entire ecosystem runs on chemical energy from hydrothermal vents and organic matter that drifts down from the surface, which scientists call marine snow. Every prediction said complex life couldn't exist at these depths. The pressure should crush any organism with hard structures. The cold should slow metabolism to nearly zero. The lack of food should prevent any population from sustaining itself. These weren't guesses. They were conclusions based on decades of deep-sea research, showing that life becomes increasingly sparse below 20,000 feet and essentially vanishes below 27,000 feet. But here's what the submarine's cameras recorded. Life, abundant, active, thriving life at depths where it shouldn't exist, and not just simple bacteria or primitive organisms. Complex animals. Animals with structures and behaviors that require energy budgets impossible to sustain in an environment with no food source. Discovery 1: a plastic bag at the bottom of the world. The first impossible thing they found was human garbage. A plastic bag lying on the ocean floor at 35,850 feet. 7 miles down in a place that had never seen human presence before the 1960s. The bag was intact, undecayed, sitting on sediment that hasn't been disturbed in millennia. Here's why this is more disturbing than it seems. That plastic bag traveled 7 miles down through water column. It likely took months or years to sink that far. The bag means that human pollution has reached the most remote place on Earth faster than we thought possible. But the real horror isn't the bag itself. It's what was eating the bag. The submarine's cameras showed amphipods, small crustaceans about the size of your thumb, crawling on and consuming the plastic. These creatures were ingesting synthetic polymers that didn't exist on Earth 100 years ago. They weren't dying from it. They were incorporating it into their ecosystem. But here's the impossible part. Amphipods shouldn't exist at this depth. These are complex organisms with exoskeletons, multiple body segments, and coordinated muscle systems. The pressure at 36,000 feet should collapse their bodies. Every amphipod species ever studied before maxed out at 26,000 feet. Finding them at 36,000 feet is like finding humans living on the surface of Mars. The environment doesn't support it. Yet there they were. Not just surviving, but thriving in numbers that suggested a stable, crop-producing population. Which means they've adapted to synthetic materials in less than a century. Evolution doesn't work that fast, but somehow these amphipods are metabolizing plastic polymers that their ancestors never encountered. Discovery 2: a supergiant amphipory the size of a dinner plate. The submarine descended further and found something even more impossible: an amphipod the size of a dinner plate. 30 times larger than any amphipod species recorded at shallower depths. It was sitting on the ocean floor, completely motionless, like it was waiting for something. Here's why size matters in deep-sea biology. Larger animals require more energy to maintain their metabolism. They need more food. At 36,000 feet, there is no food chain. No plants, no algae, no sunlight to drive photosynthesis. The only energy comes from rare chemical seeps from the Earth's crust or organic matter sinking from the surface. This creates an energy-poor environment where only small, slow-metabolism organisms should survive. A 13-inch amphipoid requires the energy budget of an organism living in food-rich shallow water. It shouldn't exist. The math doesn't work. To grow that large, it would need to consume massive amounts of food that doesn't exist at that depth. Yet there it was, perfectly adapted to an environment that supposedly couldn't support it. But here's what makes it genuinely disturbing. The amphipod was pale white with no eyes. This makes sense because there's no light at that depth, so eyes are useless, but its antennae were enormous, almost half the length of its body. And its mandibles, the jaw-like structures used for feeding, were oversized and serrated like saw blades. This is the morphology of an apex predator. The antennae are for sensing chemical signals and vibrations from prey. The mandibles are for tearing apart tissue. But what is it hunting? What prey exists at 36,000 feet that could sustain a predator this size? The submarine footage showed the amphipod moving with sudden, violent bursts of speed when it detected the submersible's lights. Whatever it hunts aggressively. And if a 13-inch amphipod can survive down there, what else is down there that's bigger? Discovery 3 snailfish that shouldn't have skeletons at 26,200 feet. The submarine encountered a species of snailfish that broke every rule of deep-sea biology. Snailfish are gelatinous, translucent fish adapted to extreme depths. They have soft, cartilaginous bodies because bones would be crushed by pressure. Every snailfish species found below 23,000 feet follows this pattern. Soft bodies, minimal structure, slow movement. The snailfish in the Mariana Trench had a partially calcified skeleton. It's not just surviving despite the pressure. It's building rigid structures that require complex biochemistry we can't explain. The fish is using cellular processes that no other deep-sea organism uses. This suggests one of two possibilities. Either this species evolved completely independently from all other deep-sea life and developed unique pressure resistance mechanisms, or there's an entire ecosystem of organisms down there that have adapted to extreme pressure in ways that violate our understanding of biology. Neither option makes sense with current evolutionary theory. And the snailfish population wasn't sparse. The submarine recorded dozens of them, suggesting a breeding population, which means there's enough food at 26,000 feet to sustain complex vertebrates with high metabolic demands. Where is that food coming from? What aren't we seeing? Discovery 4. Bacterial mats that glow at 34,000 feet. The submarine's lights illuminated something that shouldn't be possible. Bacterial mats covering sections of the ocean floor that emitted a faint bioluminescent glow. Bioluminescence requires energy. Significant energy. It's one of the most metabolically expensive processes in biology because generating light requires chemical reactions that consume ATP at high rates. Bacteria at 34,000 feet shouldn't have energy for bioluminescence. They should be operating at minimal metabolism, barely surviving on whatever chemical energy seeps from the Earth's crust. Instead, these bacteria were glowing bright enough to be visible without the submarine's lights. They were producing light in an environment with no sunlight, no food chain, and minimal energy sources. But here's what the analysis revealed. The bacterial mats weren't random. They formed geometric patterns on the ocean floor. Circles, lines, and shapes that suggested organization or communication. Bacterial colonies typically grow in irregular clusters determined by nutrient availability. These mats were arranged in patterns that implied purpose or response to stimuli. One hypothesis is that the bacteria are using bioluminescence to communicate with other organisms in the darkness. But communicate with what? What other organisms are down there that could see and respond to bacterial light signals? The snailfish don't have eyes. The amphipods are blind. What is this light for? Another hypothesis is even more disturbing. The patterns might be attracting prey. The bacteria glow. Organisms are drawn to the light, thinking it's food or another organism, and when they get close, something else predates them. The bacteria aren't producing light randomly. They're using it as bait, which means there's an entire predator-prey dynamic operating at 34,000 feet that we don't understand. Discovery 5. Rock formations that look artificial at 35,000 feet. The submarine found rock formations that looked wrong. Too geometric, too organized. Natural rock formations at these depths should be rounded by sediment accumulation and gradual erosion. These formations had sharp angles, flat surfaces, and parallel lines that suggested shaping by something other than natural processes. Here's what made them suspicious. Several formations had holes that appeared to be bored through solid rock. The holes were circular, uniform in diameter, and passed completely through rock structures that were several feet thick. Natural erosion doesn't create perfectly circular holes through solid basalt rock. Geological processes create cracks, fissures, and irregular gaps. These holes look drilled. But here's the problem. There's no known organism or process that could drill through solid rock at 35,000 feet. Some species of mollusks can bore through rock in shallow water using acid secretions and mechanical rasping. But those species max out at a few hundred feet of depth. The pressure at 35,000 feet would make any drilling or boring mechanism impossible because it requires creating structural force against resistance. The pressure would crush any organism trying to generate that force. Yet the holes exist. They're documented in hours of submarine footage. And some of the formations have multiple holes arranged in patterns that suggest intentional spacing. This could be coincidence. Natural geological processes can occasionally create regular patterns, but the statistical probability of multiple circular holes appearing in organized arrangements across several separate rock formations is essentially zero. The expedition team avoided speculating publicly. The official report listed the formations as geological anomalies requiring further study, but unofficial commentary from team members suggested deep unease. One geologist who reviewed the footage said the formations looked like structures he'd seen in archaeological sites. Except these were 7 miles underwater in a place no human has been until recently. Discovery 6. A trench within the trench. The submarine sonar detected something that wasn't on any previous map. A secondary trench, a crack in the ocean floor that descended even deeper than Challenger Deep. The sonar readings showed it dropping at least another 2,000 feet below the previously measured deepest point. That would make it 38,000 feet deep, 8 miles down. Here's why this is significant. The Mariana Trench has been surveyed multiple times with advanced sonar since the 1950s. Every survey mapped Challenger Deep as the deepest point at 36,070 feet. The discovery of an even deeper section means either previous surveys missed it, which seems unlikely given modern sonar precision, or the ocean floor shifted and created a new depression recently. Recent means within the last decade. But here's what makes it terrifying. The submarine couldn't descend into this deeper trench. The pressure rating on the submersible was designed for 36,000 feet maximum. Going deeper would risk catastrophic hull failure. So they mapped the opening with sonar and cameras but couldn't explore what was inside. The sonar reading showed the trench was narrow, only about 50 feet wide, and it descended at a steep angle into darkness that their lights couldn't penetrate. And the thermal sensors detected temperature anomalies coming from the opening. The water flowing out of the trench was warmer than surrounding water by several degrees. This suggests hydrothermal activity or some geothermal heat source deeper down, which means there's an entire deeper ecosystem that no one has ever seen. If life adapted to 36,000 feet, what has life adapted to at 38,000 feet? What organisms have evolved in an environment even more extreme than the most extreme environment we know? And more disturbing, What's producing the heat that's flowing out of that trench? Hydrothermal vents are typically mapped and understood. This heat source wasn't on any geological survey, or it's been down there for millennia and we never detected it. Here's the pattern across all 6 discoveries. Life exists at depths and in conditions that should be biologically impossible. Organisms have adapted to environments that violate our understanding of energy requirements, pressure tolerance, and evolutionary timescales. And there are geological formations that don't match natural processes. But here's what scientists aren't saying publicly. The Mariana Trench expedition covered less than 2% of the trench floor. They surveyed a tiny fraction of the deepest ocean. If they found 6 impossible things in that 2%, what exists in the other 98%? The ocean below 20,000 feet is larger than the surface of Mars. We've explored more of Mars than we have of our own ocean floor below 4 miles. We've sent rovers to Mars, orbiters to Jupiter, and probes to the edge of the solar system. But we haven't mapped the bottom of our own ocean. And based on the Mariana Trench findings, we should be terrified of what's down there. We found complex predators where nothing should survive. We found organisms metabolizing plastic after just a few decades of exposure. We found bioluminescent bacteria arranged in patterns that suggest communication or coordination. We found rock formations that look artificial. We found an even deeper trench that we can't explore. Every discovery raises more questions than it answers. What is the apex predator in an ecosystem that shouldn't exist? What created those holes in the rock? What lives in the deeper trench at 38,000 feet? And most disturbing, if life adapted to the most extreme environment on Earth this quickly, what else is hiding in the vast, unexplored darkness of the deep ocean? The Mariana Trench expedition proved one thing definitively. We don't understand the deep ocean. We don't know what's down there. And based on what we found in just 2% of one trench, we probably don't want to know, because the things that live 7 miles down aren't supposed to exist. Yet they do, and they're thriving in an environment that should be completely lifeless. Which means our models of biology, evolution, and marine ecosystems are fundamentally wrong. The submarine mapped the Mariana Trench floor and found something that shouldn't exist. Actually, it found 6 things that shouldn't exist, and those are just the ones we saw in the fraction of the trench we explored. The rest of it is still down there, 7 miles deep, waiting in total darkness. And now we know something is definitely down there with it.